Hello class, welcome to Unit 4 Video 3. The lesson for today is on factoring, and your learning target is that you can factor quadratic expressions. So the first thing we want to go ahead and talk about is what is a quadratic? Well, we've been looking at them so far this unit. A quadratic would be x squared plus 2x plus 3. That's an example of a quadratic, okay? I know it's a quadratic because it has the highest variable is something squared. To be an expression, remember that means there is no equal sign. Okay, so in this problem that I wrote here, this is a quadratic expression because there's no equal sign, and it's a quadratic because it has the highest degree of 2, or the highest exponent of 2. So what is factoring? Just going to make a little more room right here. If I have this, if I have x plus 5, x minus 2, okay? And I said to FOIL it, you would take your first and multiply it. We would have x squared. Then I would take my outer for FOIL, right? First, outer, inner, last. My outers, multiply them. I would have negative 2x. Then I move on to the inners, so plus 5x. And then my last two in my parentheses, so that'd be 5 times negative 2, which is negative 10. This simplifies to x squared, negative 2x plus 5x is 3x minus 10. This is a quadratic, okay? We are going to be starting with something that looks like this today, and we need to work our way backwards to something that is in factored form, what this is here. So this is factored form. I would call this is standard quadratic. So we're going to start with something like this today and work our way back. Okay, so what is factoring? It is simply the opposite of FOILing and the opposite of distributing. Okay. So when factoring, there are multiple types of factoring. One thing you need to be aware of is GCF. Okay, what that is it stands for the greatest common factor. So what you need to do for this is you need to factor out, or same idea as divide, by the greatest common factor. Okay, the GCF. Okay, so that's what we have for that. We're going to be looking at two types of quadratics. These are both types. If you look at, the only thing that's different here is this one has an A. So it has a number out in front. So if I go back to my example that I wrote before, oops, notice how we have an x squared plus 3x minus 10. Let's think about this. How did I get this? Well, this x squared came from multiplying my first two. Then my 3x came from these two pieces, which I got from when I multiplied my outside, my two outsides, my negative 2x, and my two insides. So that's really the OI part. And I got my last number by multiplying the last number in each set of parentheses. Okay, so that's how we have to undo FOIL. This middle part is always the hardest part. It is the OI. Okay, so going back, that's what this looks like. So this part comes from the F of FOIL, this part comes from the OI of FOIL, and C comes from the last. What we need in order to get this is, if you look back to our example again, notice how did we get negative 10? It was just from multiplying our last two numbers, 5 times negative 2, which is a product. Okay, so this one you get from doing the product. You might want to just remember that that is multiplying. And your B came from adding your outer and your inner. So this one is the sum or addition plus. Okay, so that's how we're going to figure out general trinomials, and that's when there is a 1 in front. So when you do this, your answer is going to look like x plus some number, and it can be either a positive or negative number, and x plus some other number. So what you just need to remember is that these two numbers need to multiply to our C value and add to our B value. So they have to multiply to C, but add to B. And the way you can remember that is if you have it in standard form, x squared, x, and then some number, you learn to add before you learn to multiply, right? So I got to add to this one and multiply to this one. Okay. The general trinomials in the form ax squared plus bx plus c, these are a little bit more complicated. It is when a is equal to a number greater than 1. Okay, and when you factor it, you're going to have some number and an x plus some other number, and then some number, let's back it up. Then some number and an x plus another number. Okay, so this one's going to factor and look a little bit differently. Okay, so we're going to come back and we'll do lots of examples with all of these, but these two, pretty similar idea. Going to end up getting something that looks like this. Two products being multiplied together. Then grouping. Okay, in order to take care of grouping, what you need to do is you need to think about it's always 4 terms. Okay, that means it's this one has 3 terms, so it'd have 4 terms. And the best way to do this is to group the first 2 terms and the last 2 terms let's write it out, 2 terms, and then take out the GCF of each one. GCF for each one. Okay, so there's different ways to think about factoring. These are kind of overall ideas. And we are going to touch on each one of these types of factoring over this lesson video and lesson video 4. So the first one we're going to look at is GCF factoring. You need to pull out the GCF from the factors and write it outside the remaining factors. So example 1, I would look at it and I would say 12x and 36. What do they have in common? 12. So my GCF is equal to 12. Okay. So I'm going to take note. I write the GCF out in front, and then I would say, well, what is, if I divide each one of these by 12, what do I get? 12x divided by 12 gives you just 12. Sorry, gives you just x, not 12, minus 36 divided by 12 is 3. This would be my answer with the GCF factored out. If you're not sure you did something right, just redistribute. Minus 36. It works out. But this part right here is our final answer with the GCF taken out. Okay. Looking at example 2, I have 8x squared and 16x. So my GCF for this one, well, what can I divide 8 and 16 by? I can divide them both by 8. And then I can also divide out an x from each one. So once again, I write my 8x or my GCF out in front. And then in parentheses, I'm going to divide each part by 8x. And see what I get. Well, my 8s would cancel. X squared divided by x, just x, plus 16 divided by 8 is 2, and the x's cancel. So there is my factored form. Example 3. I look at this one, 39 and 13. I wonder if 39 is divisible by 13. It is. So my GCF is equal to 13. And then the biggest x I can take out. This is an x to the first, and this is an x to the second. So I can for sure take out an x to the first from the first one, and I can take out an x to the first here. So it's 13x is my GCF. So I put that out in front of my parentheses, and I think about it as dividing each one by 13x. 39 divided by 13 is 3. X squared divided by x is just x. These cancel and these cancel. So what do I really have left here? Well, if everything, the same number divided by the same number, that gives you 1. You need to have that 1. A lot of people forget about that, but you have to think, once again, if I were to redistribute, what would I have to have there in order to get 13x? Well, 13x times 1 is 13x. Example 4. Now this one looks a little different. This one has, this is a trinomial because there are 3 pieces. So let's just look at if I can factor out a GCF first. GCF. What's it going to equal? So I have a 5, a 20, and a 40. So I can divide them all by 5. And then it's always the smallest exponent, if you guys aren't catching on to that. So here's a 7, here's a 3, and here's a 2 for exponent. So I can take out an x squared. So I'm going to divide each one. So I write that GCF in front. And then I would say 5 divided by 5 is 1. X is 7 divided by x squared. So think back to when you did rules of exponents, probably been a while. But I always take the smaller exponent and bring it to the larger and subtract. So 7 minus 2 is 5, so I would have x to the 5th. The other way to think about it is when you multiply, what do you do with exponents? You add them. So 2 plus 5 is 7. So I'm going back to where I need to be. Minus 20 divided by 5 is 4. I would just have x. And plus 40 divided by 5 is 8. So I have 5x squared, and then in parentheses, 5x to the 5th minus 4x plus 8. Okay? So these are our GCF, and you should always, this should be your first step, always check if something has a GCF. Okay? Check for GCF. All right, so those are GCF examples. Now let's look at our general trinomial. Okay, when you find two numbers that give you a product of C, which means multiply, but they have to add or sum, oops, this one they need to sum to B. All right, here is probably the best way to approach this. Write down your multiples of C, okay? So for C, I think, well, 8. Do it in a logical order. 1 times 8, 2 times 4, 3, nope, that's it. This is all my factors of 8, okay? Then I would think about, well, what multiplies to 1? It's really 1 times 1. So right away I know I'm going to have an x in the front of each one because my first two have to multiply to x squared. Well, x times x is x squared. This is my last, so that means my last two numbers have to multiply to 8. And then I can think about it as these two as a pair have to add to 6. Okay? Is there any way that with the 1 and 8 I could add to 6? I could add to 9, or if one of them was negative, I could get, let's see, -7, or if they were both negative, -9. So that doesn't work. But 2 and 6. If I add 2 and 6 together, do I get 6? Yes. So I would have +2 and +4. So here is my trinomial factored. One way to check. My first two. X times x gives me x squared. We're good there. My last two. 2 times 4 gives me 8. Now I have to check my OI. My inner, this would give you 2x when you multiply, and my outer. This would give me 4x. 2x plus 4x is 6x, so it works out. Okay? When it's a general trinomial, it's not as important to always check, but when you have a number in front of your x squared, it will be important. Also want to point out, if I have x plus 2 and x plus 4, I can write it either direction. Doesn't matter. They are both right. This answer or this one. Okay? So moving on to example 6. Once again, we are multiplying to 12. But add to 13. So multiples of 12. 1 times 12, 2 times 6, 3 times 4, 5 times there is nothing. Then you guys kind of see how I'm looping back around. So 1, 2, 3, 4, there was no 5s, and then no 7s, 8s, kinds of idea. So you have every multiple listed here. So we need to multiply to 12, but add to 13. Well, I can see 1 plus 12 gives me 13. So my answer is x plus 1, x plus 12. And I could check. My first two, x times x, x squared. My last two, 1 times 12 gives you 12. So I've got both of those. Then I would check here. This would give me, when I multiply, 1x. And this would give me 12x. 1x and 12x, 13x. So it all works out. Okay. There is example 6. Example 7. Have to multiply to my C. So multiplies to 4. 1 times 4, 2 times 2, and that is it for my multiples of 4. When you get better with this, you don't have to write these out. But if you are stuck on one, start listing out all your multiples. okay? Then let's do our parentheses. Multiplies to -4. Got to be careful here. We want -4, but adds to 3. So some might require a little bit more thinking. So to be negative, one of them is going to have to be a negative number. So let's just think about it. -2 plus 2 would give us 0, so that's not going to work. If I make my 1 negative, -1 plus 4, that is 3. So it's x minus 1 and x plus 4. There is example 7. Okay, looking at example 8, 9, and 10. Those are all special cases that we have here. They are what we call difference of two squares. And there is a sum and difference pattern that you should take note of. If I have some number squared minus, because it is difference, another number squared, I can write it as, I have x squared, take the square root of x, which gives us x, you put that in the front, and then you take the square root of whatever y squared is, and that's y, put that in the back, and then you always have a negative and you always have a plus. Okay, so let's look at some examples that have that. Here we go. I see x squared and 4, so 4 is a perfect squared, and it's being subtracted, so I can write it as x plus and x minus. Now, what is the square root of 4? 2, so it's x plus 2, x minus 2. Done. Here is the other reason this works. It is really like x squared plus 0x minus 4, because there is no b value. So it's really what multiplies to -4 and what adds to 0. Well, 1 times 4 and 2 times 2 are my multiples. And what would add? Well, if I had a -2 and a positive, that would give me 0. Either way, you get the right answer. And once again, you can write it in either direction. It does not matter. Looking at number 9. I see 64. I know off the top of my head 64. Square root of it is 8. So I would have x plus 8, x minus 8. Done. Once you start noticing the difference of perfect squares, things will go quicker because they typically come up frequently. Okay, here we go. Next one, we have x squared minus 25. Square root of x squared is x, so I have that in the front. Square root of 25 is 5. Always have a plus and a minus. There is example 10. Okay. If you feel like you might need a break, now might be a really good time to pause it and take a break, because then we're going to move on to our general trinomials, and that's with the number in front of x squared. All right, so here is our first example. We are going to disregard what this says. We are going to guess and check how to get here. Like I said before, this is different because there's a number in front of my x squared. So here it is. We got 2. Okay, so we have our FOIL. This part comes from F, our first 2. This one comes from our last, and this is our OI. The outer and the inner parts of my parentheses being multiplied. So we are trying to get this unfoiled, or back to the state of 2 factored products. So let's just start with the easy ones. Our first 2 and our last. I look at the first. What multiplies to 2? 2 times 1. What multiplies to my last number? 1 times 5. That's it. Okay, so here we go. We start writing it out. This is where it's different. If it was just an x squared, we would know it's going to be x and x right away, but that's not the case. It's 2x squared, so I'm going to have a 2x and an x. Now, here's where the guess and check comes. That's not as easy as if this was just a 1. I will put in a 1 here and a 5. I must check my outer 2 and my inner 2. So when I multiply my inners, I would have 1x. When I multiply my outers, 2x times 5, I have 10x. I would say to myself, with these 2 numbers, can I get my OI or my B value? 11x. Yes, they would both have to be positive. This is my factored form. I am done. Now, let's say that it didn't work out that nice. Maybe I started out and I had 2x, and I put the 5 here, and x and a 1. I check. This would give me 5x, and this would give me 2x. With a 5 and a 2x, can I get to 11x in any way? No. So then I would switch them around and get this answer. Okay. There is example 11. Let's go ahead and look at 12. We have this one. So let's always just list out our options for 3. What multiplies to 3? 1 times 3. What multiplies to 7? 1 times 7. That's it. So when they're prime numbers, we are super happy because there's less options to check. So I know I'm going to for sure have an x and a 3x in the front because these two numbers have to multiply to 3x squared. Now I have my 7. Okay. I am going to try 7 and 1. Those two numbers, my last two, have to multiply to my c. So far, so good. Now here's where I have to check the oi in FOIL. This, when I multiply, gives me 21x. This gives you x. 21x and x. Is there any way I can get to -4? Not that I can think of. So this is where my guessing is coming in. So I erase. And I had 7 here and 1, so now I'm going to swap them around. I'm going to try 1 and 7. This, when I multiply, gives you 3x. When I multiply this, I get 7x. With 3x and 7x being added or subtracted in any way, can I get to -4x? Yes, if this is negative. So that means that when I multiply here, this has to be negative, this has to be positive. So my answer is x plus 1, 3x minus 7. Okay. Here's some mixed practice. Okay, so when I get to my mixed practice, it means I have a little bit of everything in it. I have a GCF, I have general trinomials, and I don't see that we're going to have any grouping today, but we'll get to grouping tomorrow. So I look at example 13. Is there a GCF? They don't all have an x, so I can't factor out an x, and they aren't all divisible by the same number. So then I just go ahead and try and factor it. This is a 1, so I know I'm going to have 1 times 1, which is nice, and 36. Ooh, lots of options for 36. I would have 1 times 36, 2 times 18, 3 times, this is 18, 2 times 18, that's what I said, right? 2 times 18, 3 times 12, 4 times 9, there's no 5, 6 times 6. Okay, here's all my options for 36. And some of you might see the answer right away. Remember, we have to multiply to this one, but add to this one. So what multiplies to 36 but adds to 5? Not that one. 2 and 18, there's no way. This one I could get if I had one positive, one negative. I could get as low as 12 minus 3. I would have 9. That's not going to be it, though. 4 and 9. If I did 9 minus 4, I would get 5. So that one works. And since it's just 1 and 1 in front, I know I'm going to have an x in the front and an x. And then I would have 4 and 9. And I need it to be a positive 5. So that means I would subtract 4. So -4, positive 9. Always check that your answer is right. The first two, x times x is x squared. The last two, -4 times 9, -36. And then it's your oi, your inner and your outer, -4x and 9x. -4x plus 9x is 5x. So my answer is correct. Okay. Number 14. I look at it. Always check for GCF. Are they all divisible by the same thing? Yes, 2. So I would put a 2 out in front. If I do that, divide essentially all things by 2 and write it here, I would have x squared plus 8x plus 15. Now, this part I need to check to see if I can factor it. So this is 1 times 1, and this is 15. So we'd have 1 times 15, 2 times, oh, there's no number 2 times, right? 3 times 5, 4 times, there's nothing. So here are my options. So what multiplies to 15 but adds to 8? 3 and 5. And I have the 2. I carry that GCF down along with it. So I check. X times x is x squared. 3 times 5 is 15. This would give me 3x. This would give me 5x. 3x plus 5x is 8x. There is 14. Number 15. Once again, always check for that GCF. They're all divisible by 3. plus 4x plus 5. And now I would check if I could factor this one. So this is 1 times 1, and this is 1 times 5. So we're nice there. It's nice there, because I just know right away the only option is 1. I shouldn't put the sign in there, because we need to add to negative. And 5. All right, can I get to a positive 4? If this is negative, I would have a negative times a positive, which would give me a negative here. So is there any way to get to a positive 4 and multiply to a positive 5? Let's think about it. 1 times 5 will give us 5, but that means I can't, that adds to 6. If I do negative 1 times 5, that gives me negative 5, but that would add to 4, so that doesn't work for both. And then if I did 1 times negative 5, still multiplies to negative 5, so it doesn't work, and that would add to negative 4. So can this one be factored further? No. That's it. So not every quadratic can be factored all the way down. This might be as far as it can go. All right, number 16. Let's look at this one. This one looks a little different. Has an x squared and a y squared. Okay. No GCF. They're not all divisible by the same thing, so I'm going to go ahead and factor it as is. My first has to multiply to something x squared, so I'm going to have an x and an x, and then we have 18y squared. So that means my n number is going to have a y, because y times y will give me y squared. And then I think about my factors for 18. I have 1 times 18, 2 times 9, 3 times 6, and that's all my factors. So which one multiplies to 18 but adds to 9? 3 and 6. They're both positive, right? So 3 times 6 is positive 18, and if I add them, they're positive 9. So plus 3 plus 6. So my answer is x plus 3y, x plus 6y, and then check. If I multiply this, it gives you 3xy, and if I multiply this, it gives me 6xy, and together I would get 9xy. So here's my final answer. Okay, there's our basic factoring. Now we're going to go ahead and look at an example, kind of a geometry example. We have the area of a rectangle is, it says find the dimensions of the rectangle, okay? Hint, the area of a rectangle is length times width. It says factor to get the length and width that was multiplied. So area of a rectangle is length times width. So we're trying to figure those out. This is my area currently. So it equals 8x squared plus 10x minus 3. The first thing that I would say is there a GCF? There is not. Okay, so I need to factor it. And this one's a little bit trickier because we have the 8 in the front. So I'm just going to list out my factors of 8. 1 times 8, 2 times 4, and that's it. And then 3 is nice because it's a prime. So I know it's 1 and 3. So here's where I might have to do a little more guess and check because there's more than one option. I recommend starting with the two numbers closest. So we're going to start out with 2x and 4x in the front of our parentheses. And then let's just do 1 and 3. Then we do our guess and check. Let's just think about this though. We have 2x and 4x, so that gives us our 8x squared, and 1 times 3 gives us 3. We need to get to 10x. When I multiply my inner, I get 4x. When I multiply my outer, 2x times 3, I get 6x. With these two numbers, can I get a positive 10? Yes, but I need to multiply to a negative 3, so does that work? There's no way. These would both have to be positive, and a positive times a positive is a positive, not a negative. So that means I need to try 3 here and 1 here. I'll have to recheck these. So let's try 3 and 1. This would give you, when I multiply my inners, 12x. When I multiply my outers, I would have 2x. With these, could I add to get a positive 10 and multiply to get a negative 3? That means 1's going to be negative. If I make this negative, that would add to a positive 10. And that would mean this is negative, this is positive. So 3 times negative 1 is negative 3. When I do my inner and my outer check, I add to a positive 10. So everything works out. Here it is factored. okay? So it wants to know the dimensions of the rectangle. So my dimensions is one side is, that's not a very good rectangle, is it? It's 4x minus 1, and the other one is 2x plus 3. Or you could just write them out. You could list them. Our dimensions, 4x minus 1 and 2x plus 3. But there it is on a drawing. That is the end of Unit 4, Video 3. If you have any questions, please let me know. Otherwise, just do your best. Don't get so frustrated. It might take a few more tries, be a guess and check to get it, but once you start doing this process, it will go a lot quicker for you, okay? You'll get used to making those combinations of numbers, and then you will find the answer quicker, okay? So if you have questions, let me know. Otherwise, have a great day.